Step outside tonight. Look up. Find Orion. Count the stars on his shoulders. There are two. There have always been two, but astronomers just confirmed something that is going to make that sentence permanently, irreversibly false. And the countdown has already started. Not in a century. Not in 1,000 years. The models that promised us safety and distance and time have just been shredded by new data coming off the world's most precise telescopes. Data that nobody was expecting. Data that changes everything about what we thought we knew about the star sitting 640 light-years away, watching us, waiting, building pressure in its core like a bomb that someone already lit the fuse on. The question is not whether Betelgeuse explodes. The question is whether it already has. Here is what is terrifying. The light reaching your eyes when you look at Betelgeuse tonight is 640 years old. You are not seeing the star. You are seeing a photograph taken in the 1380s playing on a cosmic delay, arriving at your retina right now as if it is live news. But it is not live. It is ancient. And the actual star, the real Betelgeuse existing in this moment in 2025, could be a cloud of expanding plasma. A neutron star the size of a city spinning at 700 revolutions per second, where a supergiant used to be. We have no way of knowing. We are watching a ghost. And the ghost just started screaming. Let's start with the data because the data is what shattered the timeline. Betelgeuse is not a normal star. It never was. It is roughly 700 times the diameter of our Sun. If you put it at the center of our solar system, its surface would swallow Mercury, Venus, Earth, and Mars. The entire inner solar system, gone, consumed, inside the star. It burns at a surface temperature of roughly 3,500 Kelvin. Cool enough by stellar standards to glow deep red, the color of warning, the color of ending. And it is classified as a red supergiant in the late stages of its life cycle, meaning the core has been burning through progressively heavier elements for millions of years. The standard model said, "Relax. Betelgeuse burns helium, then carbon, then neon, then oxygen, then silicon, and silicon burning is the final stage. Once that starts, you have weeks. But we were told the silicon burning was still far off. 100,000 years, maybe more. Plenty of time. No urgency. Just a beautiful red star to admire on cold winter nights." Then came 2019. Betelgeuse dropped in brightness by 60%. To the naked eye, it was visibly dimming in real time, which almost never happens with massive stars. Astronomers scrambled. The immediate explanation, a surface mass ejection. The star coughed. It vomited a chunk of its own outer atmosphere into space. The material cooled, condensed into dust, and the dust cloud drifted between Betelgeuse and Earth, blocking the light. Temporary. Harmless. The star would recover. That was the story they told. That was the explanation that made everyone feel better. But then astronomers went back and looked at the temperature data. If the dimming was caused entirely by an external dust cloud, the surface temperature of the star itself should have remained unchanged. The dust is just in the way, like fog in front of a lighthouse. The lighthouse is still burning, but the measurements from 2019 and 2020 are showing the surface temperature of Betelgeuse dropped significantly during that event. Not a dust cloud. The star itself cooled down. And that changes everything. A surface temperature drop of that magnitude, that sudden, means the convective cells inside the star, the enormous, churning columns of plasma that carry energy from the core to the surface, those cells destabilized. They collapsed. The star was not just blocked from our view. The star was choking from the inside. And no standard model had predicted that. No standard model had even considered it possible at this stage. Follow-up spectroscopic data from 2020 through 2024 confirmed the nightmare. Betelgeuse was not recovering normally. Its pulsation cycles, the regular rhythmic expansion and contraction it had maintained for decades, those cycles had broken. The star was pulsating erratically, irregularly, like a heartbeat going arrhythmic under extreme stress. And the outer layers were continuing to shed mass into space at a rate faster than any previous measurement had recorded. Mass loss is the critical variable. Every kilogram of material Betelgeuse bleeds into space reduces the outward pressure that holds the core against gravity. Less outward pressure means the core compresses more. More compression means the temperature and density inside the core rise. Rising temperature and density accelerate the fusion of heavier elements. And accelerated fusion of heavier elements means you reach silicon burning faster. Silicon burning is the point of no return. Once it starts, you have weeks, maybe days. And then astronomers found the companion star. This is the discovery that collapsed the timeline completely. Buried in archival data from multiple telescopes, confirmed in late 2023 and refined through 2024, a second object orbiting Betelgeuse. Small, dense, likely around 1 to 2 times the mass of our Sun. Astronomers have named it Alpha Orionis b, though many are calling it the companion informally in ongoing papers. It completes one orbit around Betelgeuse every few years. But here's the catastrophic detail. Betelgeuse is so bloated, its outer atmosphere so extended and diffuse, that the companion's orbit carries it directly through the red supergiant's outer envelope on every pass. Imagine throwing a bowling ball through fog, but the fog is superheated plasma at 3,500 Kelvin. The bowling ball is a star, and it is doing this repeatedly, on a fixed orbital schedule, dragging material away with its gravity, disrupting the convective cells, amplifying mass loss with every single pass. The 2019 dimming event. The spectroscopic records are now confirming it coincided almost exactly with a close orbital approach. The companion plunged through. The gravitational interaction ripped a convection cell free. The ejected plasma launched into space, cooled, formed a dust cloud, and blocked the southern hemisphere of the star from our view. That is why the brightness dropped 60%. Not a random stellar hiccup. A gravitational assault from a star we did not know existed. And it is doing it again. Current observations from ALMA, from the Very Large Telescope Array, from the James Webb Space Telescope, are showing a trail of concentrated stellar material streaming behind the companion's most recent orbital pass. A wake of ejected plasma cooling in real time. A new dust cloud is forming, and based on orbital mechanics and the mass of material involved, this next dimming event could be significantly worse than 2019. If the core of Betelgeuse is as far along in silicon burning as some models now suggest, another major convective disruption might be the last push it needs, the last increment of mass loss that tips the gravitational balance. The moment gravity wins. And gravity winning in a star of this mass is not a gentle event. When the core collapses, it happens in less than a second. The iron core, which cannot be fused any further because iron fusion absorbs energy rather than releasing it, suddenly loses the thermal pressure holding it up. Gravity crushes it from basketball-sized to the size of a city in under a millisecond. The implosion is so violent that it rebounds, sending a shock wave of unimaginable force outward through the entire star. The outer layers are not just pushed away, they are blown apart at a significant fraction of the speed of light, releasing more energy in seconds than our Sun will emit in its entire 10 billion-year lifetime. That is a supernova, and when it happens, the very first thing to reach us will not be light. It will be neutrinos. Subatomic particles with almost no mass, no charge, barely interacting with anything, streaming out of the collapsing core at nearly the speed of light, arriving at Earth hours or perhaps a full day before the visible light wave. Underground detectors in Japan, Canada, and Antarctica, massive chambers of ultra-pure water surrounded by thousands of photomultiplier sensors, will register a burst of billions of neutrinos in the space of a few seconds. On a normal day, these instruments detect a handful of neutrinos from the Sun and cosmic background radiation. When Betelgeuse collapses, the spike will be instantaneous, unmistakable, and absolute. Scientists monitoring those detectors around the clock will know in real time. Automated alerts will fire. Phones will ring at observatories across the planet. The message will be brief. Betelgeuse has collapsed. The light is on its way. You have hours. Look east. What happens next will be unlike anything in the recorded history of human civilization. The light arrives. If you are awake, if you are outside, you will see Orion shift. The red star on the hunter's left shoulder will bloom, not dramatically at first. A flicker of intensity, a deepening glow, but within the first hour, it surpasses every star in the sky. Within a few hours, it surpasses Venus. By the time the night deepens, Betelgeuse is burning at a brightness that will cast sharp, defined shadows on the pavement. You will hold your hand up and see two shadows. One from the streetlight above you, one from the dying star on the eastern horizon, red and cold and long, pointing west. And it will not stop there. Astronomers modeling the event project peak brightness somewhere between magnitude -10 and magnitude -12. For reference, the full moon sits at magnitude -13. Betelgeuse at peak will be close to that, not spread across the disk of the moon, but concentrated, a single, blinding point of light, focused and fierce and piercing. Bright enough to read by at midnight. Bright enough that it will remain visible after sunrise. Bright enough that when you step outside at noon on a Tuesday, grocery bags in hand, you will look up and see it. A second sun, smaller than the real one, reddish-white, hanging in the eastern sky. Undeniable, impossible to ignore. Both suns visible simultaneously in a blue daylight sky. For roughly 3 months, this will be the reality of every human being alive on this planet. No location excluded. No hemisphere excluded. Betelgeuse sits on the celestial equator, visible from almost every point on Earth's surface. Every culture, every country, every person who looks up will see it. And none of them will be able to look away. Because there is something ancient and biological in us that responds to change in the sky. Our ancestors navigated by those stars. They built calendars around them. They named their gods after them. The sky was supposed to be permanent, eternal, fixed, and now it is not. Social and cultural disruption will be immediate and total. Markets will react. Religious institutions will respond. Governments will issue statements. Scientists will appear on every channel simultaneously trying to reassure a species that is not built to process this. Because no amount of scientific explanation will prevent the primal recognition that something fundamental has changed. Something large and ancient and bright died, and we can see it with our own eyes in broad daylight. And there is something even more profound beneath the spectacle. The light you are seeing when Betelgeuse explodes will have left the star 640 years ago. You will be witnessing an event that happened in the 1380s, playing out in your sky in real time. The star has been dead for centuries. It has been traveling toward you for 640 years. And it is finally arriving. You are not witnessing a death. You are witnessing the announcement of a death that already happened before Shakespeare was born, before Columbus sailed, before the printing press existed. The universe held this letter for 640 years, and is only now slipping it under your door. That gap between event and observation is one of the most philosophically disorienting truths in all of astronomy. We talk about space as something vast and abstract, but this makes it visceral. The universe is so large that a star can die, and the news takes longer to arrive than the entirety of recorded modern human history. After 3 months at peak brightness, the light curve will begin to fall. Slowly at first, then faster. Magnitude -12 becomes -8, then -5, then -2, then below the naked eye limit within a year, and what remains will be a faint, expanding cloud of gas and plasma, a supernova remnant slowly pushing outward into interstellar space, thousands of degrees and still growing, seeding the galaxy with carbon, oxygen, nitrogen, iron, the raw materials that will eventually collapse into new solar systems, new planets, new oceans, potentially new life. The death of Betelgeuse will be the birth of something we cannot yet imagine, and at the center, if the physics holds, a neutron star, a sphere roughly 20 kilometers across. The compressed remnant of a stellar core that was once twice the mass of our Sun, now packed into a ball smaller than most cities, with a surface gravity 200 billion times stronger than Earth's, spinning, possibly emitting pulses of radiation with the regularity of an atomic clock. A pulsar, a cosmic lighthouse running on the leftover energy of a catastrophe that happened while medieval peasants were plowing fields under a sky that still had 2 normal stars on Orion's shoulders. And Orion will be broken. Permanently. Irreversibly. Future children will be taught that the constellation used to have 2 shoulders. They will see archive photographs of what the winter sky looked like before. They will never experience it. The hunter will be asymmetric forever. One shoulder bright, one shoulder dark, one shoulder gone, scattered across 50 light-years of glowing remnant gas. But here's the question that no one is sitting with long enough. If this is what happened to Betelgeuse, a nearby supergiant that every model rated as stable, a star we have been watching for centuries and only just discovered has a hidden companion actively stripping it apart. What does that mean for everything else we have rated as stable? Antares, Rigel, Deneb, VY Canis Majoris, all massive, all within several thousand light-years. All assigned comfortable timelines by models that were built before we discovered that companion stars can hide inside a red supergiant's atmosphere and tear it apart from within. How many of them have companions we haven't found yet? How many of them are already in late-stage silicon burning? The news just hasn't reached us. How many of those ghost photographs we call night sky observations are already showing us dead stars, their deaths in transit, their announcements 200, 500, 800 years from our door? The universe did not ask for our permission to accelerate. It did not wait for our models to catch up. It did not hold its timeline so our textbooks could stay accurate. It is moving at its own pace, on its own schedule, governed by physics that does not care whether we have detected the companion star or not. The companion is there either way. The mass loss is happening either way. The core compression is accelerating either way. And the light, 640 years old, carrying the last coherent image of a living Betelgeuse, is all we have right now to understand a star that may have already stopped existing. We are standing in 2025 looking at 1385. We are holding ancient light in our eyes and calling it observation. We are watching a ghost and calling it science. And the real star, the one living in actual, present-tense cosmic time, is beyond our reach, beyond our instruments, beyond our knowledge until the neutrinos arrive. That is the truth of where we are. That is the scale of what is coming. Not a headline, not a spectacle. A fundamental rupture in how humanity understands its place in the sky, its relationship to the stars, its assumption that the cosmos is stable background scenery rather than a violently dynamic, collapsing, exploding, evolving system that we are embedded inside of, not separate from, not above, not observing from a safe distance, but inside, living inside, breathing the stardust of ancient supernovae, waiting for the next announcement to arrive. Two suns, possibly already forming in the sky above you, their light in transit, their message sent centuries ago, their arrival inevitable. So here's the question I want you to sit with. Not a quick one, a real one. If the universe is this dynamic, this violent, this indifferent to the timelines our science assigned it, and if we are only now discovering hidden companions destabilizing the stars we thought we understood, what does that say about our models of everything else? What does it say about how we understand stability itself? And when that second sun finally blazes over your horizon, when you stand in daylight and cast two shadows, what will it mean to you personally that the universe just overruled every prediction we made? Tell me below, because I think this is the beginning of a new kind of humility. The kind that comes not from failure, but from finally seeing clearly how vast and untamed and alive this cosmos actually is. Subscribe, because when those neutrino detectors spike, when the alerts go live, when the light finally arrives, you are going to want to have been part of this conversation from the beginning. We are watching in real time, or as close to real time as 640 light-years will allow, and that is close enough to matter.